If you're designing a part that's symmetric, you can save yourself time by using the mirror feature. With the mirror feature, you can replicate individual features, faces, or bodies. In this lesson, we'll take a look at mirroring features and one special case of mirroring bodies. When we talk about features, we're talking about 3D geometry, like this cutout here. In order to mirror 3D geometry, we need to have a plane, or a flat face to use as a reference. In this case, if I show the right plane, you can see it passes through the center of this part. I'll be using this plane to mirror the cutout. The mirror feature can be launched using this icon, or from the drop-down menu. Like with other features, all I have to do is go through the options in the Property Manager and click the green check to finish. First, I have to indicate which face or plane I want to use as my reference. I can select the plane here, or from the Feature Manager. Next, I need to specify which feature I wish to mirror. As with the plane, I can either select the feature from the Feature Manager tree or directly from the graphics window. To select a feature graphically, you must select a face that is unique to that feature. For example, to select the keyhole slot, I need to select one of these faces which is unique to the cut. If you hover your cursor for a second over the face, a flag will also pop up identifying the feature that you're hovering over. After selecting a feature to mirror, right away you can see a preview of the geometry that will be replicated. To finish, I just click the green check and I'm done. Just like other features, the mirror feature will be listed in the Feature Manager tree. If I need to make a change, I can right-click on it and select Edit Feature. In this case, for example, I can add the boss to replicate both features at the same time. There may be times when the plane you want to use for mirroring is not one of the default reference planes front, top, or right. In such cases, you can create your own plane. In this example, I want to mirror the slot over to the other side of the block. However, if I take a look at my reference planes, none of them pass through the center of the part, so I'll have to create one that does. I can use the plane icon, or the drop-down menu under Insert, Reference Geometry, and select Plane. The Plane Property Manager displays 3 selection windows to define references. In a future lesson, I will go more in-depth about creating reference planes, but for now, I'll go ahead in defining a plane to mirror about. I'll click on the face that's parallel to the plane I want to create to define my first reference. Once I click on the face, a number of icons appear underneath. Each of these buttons represent different methods of defining a plane. The default option is Offset Distance, since it is the most commonly used. This allows me to create a plane that is offset from an existing plane or flat face. I can choose which side the plane should be on and how many planes I need. For this example, it's important that the plane I create ends up exactly in the center of the part. To accomplish this, I can use the Parallel option. Here I can choose a plane or face to be parallel to, and a point to tell SolidWorks how far the plane should be. When I hover over this edge, a small box appears showing the location of the midpoint. When I click on it, you can see the preview now shows a plane that is parallel to this face at this point, and that is exactly what I want. Also, the message window is now green and says Fully Defined, telling me that the plane can be created as wanted. Now I can use this new plane to create the mirror feature. If the part you are modeling is completely symmetric, you can save even more time by modeling half of it and replicating the entire thing rather than individual features. The same mirror feature is used to accomplish this. Instead of selecting a plane as my reference, I'll select this face. Since I'm not going to mirror individual features, I won't select anything in this window. Instead, I'll use the Bodies to Mirror window and pick any face of the model. Again, you'll see a preview of the geometry that will be replicated, and the green check will finish this feature. Another way to save time when creating parts is to pattern repeating geometry. In this example, I want to replicate this hole into a series of holes. The series of holes will be organized into straight lines, so I'll use the linear pattern feature, also available from the drop-down menu. First, I specify the direction of the pattern. I specify the direction by selecting an edge, and using this button to flip the direction from one side to the other. Next, I type in the spacing for the pattern. I can type in a value here, or using the flag in the graphics window. This field is where I specify the number of instances for the pattern. Again, this can be set here or in the graphics window. If the pattern is to have two directions, I can complete the information for the second direction here. We'll come back to this in a moment. For now, I'll use only one direction. Now I can select the features, faces, or bodies I wish to pattern. For this example, I'll select the whole, either from the Feature Manager tree or the graphics window. Right away, I'll be able to see a preview of the pattern. The preview will update as adjustments are made to the spacing and number of instances. Once the settings are OK, the check will finish the command and the pattern is in place. Like other features, I can right-click and select Edit Feature to make changes. This time, I'll activate the second direction. I can choose whether I want to pattern all instances in the second direction or only the original hole by using the Pattern Seed Only option. If I wish to skip certain instances, I can use this option here. Each point I select will be a skipped instance. If I want to retrieve the skipped instances, I simply edit the pattern and delete the skipped instances from the selection window. In cases where geometry is repeated in a circular fashion, a circular pattern can be used. This is the icon for a circular pattern. Like most other features, it can also be launched from the drop-down menu. The first field prompts me to specify the center for the pattern by using an axis, a circular edge, or a cylindrical surface. I can create circular patterns of features, faces, or bodies. In this case, I like to pattern the whole. I can select it in the graphics area directly or from the Feature Manager tree. Because I've got the equal spacing option checked, you can see in the preview that as I change the number of instances, SolidWorks will evenly distribute the holes. This is true whether I'm using 360 degrees or any other value. If I clear the equal spacing option, I can directly control the spacing between each hole. I can complete the feature by clicking the check. Now that you know how to create a pattern, I'd like to show you how to vary instances in a pattern. For instance, if you want a slot to get bigger as it is patterned, SolidWorks gives you the flexibility to vary any instance or instances of a pattern that you need. Here I have a part with a really simple linear pattern already created. I'll edit the pattern feature, and in the Property Manager, notice the Instances to Vary section here at the bottom. I'll select it. When I do, the Pattern Features dimensions appear, and I can choose the dimensions I'd like to vary. Once the dimensions are selected, the table populates with the values. Under Direction 1, I'll set the spacing, and I'll set the increment that I'd like to vary the pattern by. When I click the green check, you can see the updated pattern's results. You can also modify the dimension of a single instance. I'll edit the pattern once more. To modify a single instance, just hover the cursor over the instance marker. Then click and select Modify Instance. If I instead selected Skip Instance, it'd be removed from the pattern. A flag appears, and you can override any of the values here. And when I click the green check, the pattern updates once more. If you decide to restore any of the instances to their original state, you can do so by editing the pattern. And in the Modified Instances box, just right-click the instance and select Delete, or remove all the modifications at once by right-clicking in the box and selecting Clear Selections. This functionality is the same for the Circular Pattern tool as well. A fill pattern is a type of pattern that automatically creates instances of a feature within a specified area. One application for this would be to create a ventilation hole pattern. In this example, I'll be creating a hole pattern on this sheet metal part. Although I'm using a sheet metal part here, fill patterns can be created on any SolidWorks part. There are two basic elements for a fill pattern: a feature to serve as the seed for the pattern, and an area to fill with the seed feature. The seed feature can either be a pre-existing feature or one of 4 shapes available in the Fill Pattern Property Manager. The area can be defined by a flat face, a sketch, or a curve on a flat face. Fill Pattern is available along with other pattern types from the icon or from the Insert Pattern Mirror drop-down menu. I'll select the Fill Pattern and the Fill Pattern Property Manager appears. I'll use this sketch as the fill boundary and choose a circular layout for the pattern. Before specifying the parameters for the pattern, let's take a look at the shape I'll be patterning. You'll find 4 shapes here in the Shapes to Pattern section. I'll select a polygon with 6 sides and a 4 mm outer radius. Now that I know the size of the shape I'll be working with, I can make better decisions about the rest of the pattern parameters. I'll set the spacing to 9 mm. Here I can choose whether I wish to specify the spacing of the individual instances of the pattern, or if I want instead to specify the number of instances in each loop of the pattern. Let's choose instances per loop and see what the results look like. I'll set the number of instances to 5 and set the margin to 0. Finally, I need to specify a direction. This will set the starting direction for the pattern. If I click the vertical edge, notice the preview shows a row lined up with the edge. If I click the direction arrow in the graphics area, the direction is reversed. The preview shows the result of using the instances per loop option. I have 5 instances of the polygon in each loop. This isn't a very effective layout for ventilation, so instead I'll choose target spacing. I'll set the spacing between instances to 9 mm, and I'll leave the margin at 0. You can see the preview now looks more like a ventilation pattern. Before clicking OK, let me draw your attention to the margin parameter. Although I've set it to 0, you can clearly see there's a space between the outermost loop and the circular boundary. This is because if another loop was added, the margin would not be satisfied. If I want to make sure the last loop is added regardless, I can set the value of the margin to a negative value. Another way to replicate geometry on a part is by using something called a curve-driven pattern. Here on this part, I want to pattern this cutout around the top surface of this part, but it would be impossible to use a linear or circular pattern to achieve this. With a curve-driven pattern, you can use a curve to drive the pattern's direction. If I look at the Feature Manager tree, I can see the sketch that was used to create Boss Extrude 1, which created the shape of the outer profile of the part. This sketch will be used to define the pattern direction of the curve-driven pattern. To begin a curve-driven pattern, I'll launch it from the Pattern Mirror icon. And when I do, the Curve-Driven Pattern Property Manager will appear. The first thing I need to do is tell SolidWorks the pattern direction. As I mentioned a moment ago, I can use a model edge or an entire sketch to define the pattern direction. To select the sketch for Boss Extrude 1, I'll select it from the Feature Manager tree. When I select the sketch, the direction path is shown in the graphics area. If it's not going in the right direction, you can click the Reverse Direction button or click the gray arrow in the graphics area. Next, I'll type in the number of instances I want to appear. and use the equal spacing option to have the instances spaced evenly throughout the curve I selected. Just a side note, the reason I use the profile sketch of Boss Extrude 1 rather than a model edge in this case is that the sketch contains all of the contours that make up the overall profile of the part. If I were to instead use a model edge for the pattern direction, the instances would be patterned evenly only around the particular edge I selected rather than around the whole part. For now, I'll leave these other options how they are and move on to tell SolidWorks which geometry I wish to pattern. I'll activate the Features to Pattern window and to select the Cut feature. As I do so, you'll see a preview of the pattern appear. The preview shows the pattern feature, but the holes aren't appearing on the surface of the part. To correct this, I'll need to adjust a couple of the options that we skipped above. The first one I'll adjust is the curve method. I'll change this to Offset Curve rather than Transform Curve, and now the preview looks correct. The other thing to notice is how the instances of the cutout are aligned with each other. They are all aligned in the same orientation as the seed. This leads to different wall thicknesses at various points around the perimeter. If I wanted to keep a constant wall thickness, I can switch this to Tangent to Curve so that each instance has the same tangency to the curve as the original seed feature. To complete our curve-driven pattern, I'll simply click the green check and the pattern is created. If for any reason you want to make changes to the pattern feature, such as adding more instances, simply click on the curve-driven pattern and choose Edit Feature. There are many instances where you need to create a circular pattern, but there are no temporary axes available where you need them. In this example, I want to pattern the hole about the center of the hexagon. Since I don't have a cylindrical face to produce a temporary axis, I have to create my own. An axis is a piece of reference geometry. To create one, I go to Insert, Reference Geometry, and select Axis. Or I can use the axis icon. These are the different ways to define an axis. The option you choose will depend on the geometry you have to work with. In this case, I have two planes that cross the center of my part, the front plane and the right plane. So I'll select the Two Planes option. In the selection window, I simply pick the two planes and you can immediately see a preview of the axis. When I click OK, the axis is inserted and it can be used to create the circular pattern.